presentation will analyze how alternative power sources can be used, such as from solar radiation, and how it can be applicable to a plethora of applications. Solar radiation comes from two main types, which are direct beam radiation and diffusive radiation. The main uses of solar radiation is the conversion of aforementioned into thermal energy and electrical energy.
PV cells are used to convert light energy into electrical energy, which is through the photovoltaic effect. PV cells are synthesized utilizing a thin slab of pure silicon, with the n-dopant usually being phosphorus and the p-dopant usually being boron. Phosphorus has one electron present in its outer shell than silicon, however boron has one less. These dopants create the electric field that motivate the energetic electrons out of the cell created when the lights strike the PV cell. The phosphorus provides the slab of silicon an excess of 3 electrons, while the boron gives the slab of silicon a positive character. The silicon slab has equal parts protons and electrons. However, some of the electrons do not have strong electrostatic forces of attraction to the nucleus, and therefore free to move within the layer. Junction is where the n-type silicon and p-type silicon meet, forming a barrier. This is due to 3 electrons of the n-type moving to the p-type for a split second, then forming a barrier to prevent any more electrons moving. When both sides of the silicon slabs are doped, this creates an imbalance in the charges at the p-n junction, which consequently produces an electric field between the two. To summarize, photons of light strike the electrons of the atoms, and these are attracted to the positive charge of the n-type and repelled by the p-type to create a flow of electrons and in turn an electrical charge. A single PV cell produces 2 watts of power, therefore these are constructed into a weather-tight, portable module. Finally, these are assembled into an array or panel to produce ample power for the necessities. In the table, the monocrystalline silicon is the most efficient whilst requiring the least surface area. Additionally, it is more available on the market and highly standardized, however has the highest capital cost and waste of silicon during production. Several applications to the use of electrical power derived by solar radiation. However, due to the high level of emissions from cars, this can be nullified by charging electrical vehicles through solar panels. Shown is an indication of prominent geographical locations available to generate power from PV cells. Locations such as the UK can still be effective for PV cells to capture enough energy through sunlight, despite not being the best location to capture infrared heat. Due to recent technological advancements, prices in PV have been significantly reduced whilst also increasing its efficiency. PV cells have contributed towards electric costs being less than $1 per watt as of 2008. Solar generation systems that utilize grid-connected systems require higher capital costs per each watt generated, due to additional installation costs associated with the grid system. Hence, traditional rooftop systems are typically employed to generate solar energy for domestic use. It demonstrates that the theoretical price of solar energy per gallon is approximately half the cost of the current global average price of gasoline, and although the infrastructure costs such as setting up solar energy recharging stations for electric vehicles are quite high, the overall long-term economic gain will eventually surpass the high initial cost. After this point, the overall economic gain accumulates exponentially for the companies that have invested in this technology, as maintenance costs are minimal. Solar energy is a great alternative to traditional non-renewable means of power generation, as it eliminates greenhouse gases and noise pollution. There is a high demand in developing countries for projects such as the rural electrification. However, other factors must be considered, such as the toxic chemicals used in its manufacturing process and energy used for the production. These are the typical costs associated with PV installation. PV pros and cons. Thank you for listening.